This is an overview of Project Pacific. Project Pacific fundamentally changes how developers get access to vSphere infrastructure and how IT operations provides governance. vSphere has been re-architected to include a Kubernetes control plane for managing workloads on ESXi hosts. We call this the supervisor cluster. Kubernetes pods deployed on the supervisor cluster run directly on ESXi in a new native pod runtime that provides the security and performance of a VM with the small footprint and fast startup of containers. The supervisor cluster will run a service that allows development teams to provision their own Kubernetes clusters on demand. There are additional services to deploy traditional virtual machines and even third-party applications. Developers accomplish this with the same tools they use with any other Kubernetes application deployment. IT operations will continue to use the familiar vSphere client to manage the environment. The Kubernetes concept of a namespace has been integrated into vCenter, enabling IT to manage policy and governance of a whole application consisting of many VMs, native pods, and even Kubernetes clusters. Namespaces provide a resource envelope managed by IT into which developers can self-service their own cloud resources. Operations teams have a single view of the policy and workload activity for a namespace. CPU and memory limits can be added. Each namespace is backed by a vSphere resource pool that enforces these limits. Container-specific limits can also be set and are enforced through Kubernetes limit ranges. vSphere storage policies can be assigned to namespaces. This assignment causes storage classes and resource quotas to be created and enforced in the Kubernetes cluster itself. Storage quotas can be defined by namespace or storage policy. Finally, the operations team provides access to the cluster through the namespace, and developers access the namespace by downloading the upstream Kubernetes CLI and API tools. Developers can use standard kubectl with the vSphere plugin to handle authentication. The login command also builds the Kubernetes config file that provides appropriate access to the cluster. Creating clusters with the vSphere Kubernetes service is done through applying a simple declarative specification file. ESXi native pods and even virtual machines can be deployed in the same way. Real-time information through the vSphere client is available in new Kubernetes cluster pages. ESXi native pods details are available as well. And of course, VM information in the same inventory.